My name is Muhammad Sultan from class 11A, and one who made this PowerPoint is Abdurrahman Ibrahim, also from 11A. And today I'll be reviewing with you or teaching you Module 7, Lesson 1, the covalent bond. And as we all know, chemistry is the best science, the words of Miss Annie. Now, in this video, I'll be covering why do atoms bond in the first place? Why do they bond ionically, covalently, uh, form hydrogen bonds, so on and so forth. And of course, the main topic of this lesson is what is a covalent bond? And finally, the types and strength of covalent bonds. So why do atoms bond in the first place? Well, two main reasons. Number one is gaining stability. The stability of an atom, ion, or a compound is related to its energy. The lower the energy, the more stable the atom becomes. And as we all know, some elements in the periodic table, they're very unstable elements, and they tend to bond with whatever that they can to form an octet, or to fill the outermost energy level of valence electrons. Ionic bonds, metals and nonmetals gain stability by transferring or receiving electrons. In a covalent bonding, atoms share the electrons between each other. Right. So atoms tend to bond with other atoms to form stable, noble gas configuration. So they are stable, uh, or they fill the outermost energy level of valence electrons. All right. And what is the covalent bond? So basically, a covalent bond is a result from sharing of electrons, the valence electrons in the outer shell. And covalent bonds result in the formation of molecules. Uh, because in ionic bonds, we form obviously ion, and in the hydrogen bonds, we form hydrogen bonds. But in covalent bonds, we form molecules. The majority of covalent bonds occur between non-metallic elements. And one thing you should know when you about this lessons is diatomic molecules, right? So normally you have the electrons are bonding that to complete the outermost shell, and it's either they're missing two, or they're missing three, and they share with others to complete the filled spots, to have a complete balanced electron of eight. But some, which are diatomic molecules, such as hydrogen, nitrogen, fluorine, oxygen, iodine, fluorine, and bromine, exist as diatomic molecules because they're more stable in the form of a molecule. All right. So these atoms combine together as a pair and not as a one atom, because they're more stable in that way, and they bond as a pair. They always come as a pair. Uh, Here's a good mnemonic to remember these atoms is have no fear of ice cold beer. H for hydrogen, N for nitrogen, F for fluorine, O for oxygen, I for iodine, C for chlorine, and B for bromine. All right. And the stable arrangement of the atomic bonds exists at the point of maximum net attraction, where the atoms bond covalently and form a molecule. And what this means is basically that if you add these two together, it will have a net of zero, right? So, for example, like the fluorine atom, it's -1, and then because it's in the group 17, it's missing one. So if you look at the hold on, let me annotate here, right? So if you look at here, they're missing one. So sorry, hold on. These two valence electron will combine together, and they will share these two, right? It's not there's no transferring, there's no giving or receiving, right? It's literally just sharing two to have each of them have eight. So if you look at this, is a great representation of covalent bond, where one atom, if you look at one atom for the left side of the fluorine atom, it has complete eight. 1, 2, 3, 4, 5, 6, 7, 8. But if you look at the right one, it's complete eight. 1, 2, 3, 4, 5, 6, 7, 8. Now they both form complete octets by sharing one of their valence electron each, right? So this one goes here, and that one goes there, right? And so they will be sharing them. And the ones that are not shared, they are called lone pairs. This is a very a question that Miss Annie might give you in your test, that she might quiz you on about the key term, and they are called lone pairs. And these lone pairs are counted as pairs, not a single electron, but a pair of electrons. So the one fluorine atom has a lone pair of three, because there's three pairs, not six. All right, that's one misconception that we cleared out. Anyways, moving on to the types and strength of covalent bonds. So in covalent bonds, there are different types because obviously different atoms have different number of valence electrons and resulting different types of uh, covalent bonds, right? And in a single covalent bond, this happens only one pair of electrons shared. And these single covalent bonds are called sigma bonds. Group 17, group 16. Group 17 has one element, sorry, from group 17 has one single bond. Elements from group 16 can make two single bonds, and elements from group 15 creates three single bonds. And these are called sigma bonds. These occur when the pair of shared electrons is in an area centered between the two atoms. And then we also have double bonds. A double bond is when two pairs of electrons are shared between two atoms. For example, oxygen, right? So oxygen is in group 16, so it needs two electrons to complete an octet. So what happens is two valence electrons from each oxygen come together and share to create an octet. All right. So let me annotate for you here. So if you look at here, this one oxygen atom will have 1, 2, 3, 4, 5, 6, 7, 8. Will have 8. And if you go on the left side, this will also have 8. 1, 2, 3, 4, 5, 6, 7, 8. They are sharing two atoms, or they are sharing two pairs and four electrons to complete the, to complete the valence electron. Let's move on to the triple bonds. The triple bond forms when three pairs of electrons are shared between two atoms. All right. This is basically the next step of the double bond. It's not that hard. It's very simple. It's just instead of one or two pairs, it's three pairs because they're missing three valence electrons. And finally, we have a pi bond. So before we talked about the sigma bond, and now there's a pi bond. And pi bonds only occur in multiple covalent bonds. And in multiple covalent bonds, you either have one sigma bond and two pi bonds. And what is a pi bond? It's basically a bond that forms when parallel orbitals overlap and share electrons. Now, here's the difference between pi bonds and sigma bonds, right? Pi bonds, they overlap together and they're parallel, right? But sigma bonds, they're not parallel. I'll show you why. So sigma bonds, they're connected in this way, in that order. So this one is parallel, and this is we could say that's perpendicular. And basically that's all for pi bonds. And how can we know what the strength of the covalent bonds, how can we tell in which one is stronger, which one is not? But basically the strength of the bond depends on the distance between the two nuclei, which is what? The bond length. And as of course the length increase, the strength decrease, just like gravity. So the closer you are together, the stronger the force is. And the amount of energy required to break the bond is called the association energy. And the association energy increases as the bond length decreases. Basically, what I'm saying is the closer the atoms are together, the stronger the bond is. And obviously, the stronger the bonds, the harder they are to separate, which means what? The energy to break the bond increases. So in simple terms, the closer together, stronger they are, more energy need to break. That's easy. And that's all I have today for you this video. And I hope this revision video was helpful for you. And I hope I can help. And good luck and whatever tests or classwork that Miss Annie throws at you. Thank you for watching.